Hello, everybody. We're going to be continuing our work in Unit 3 today. We're going to be working, or at least starting to work on Part B, arrays and loops today. So if you can go ahead and get to your playground folders and open up that particular playground, you can see I'm in that spot here. So I'm going to load that up into Xcode. I will trust and open, and we're going to start pushing through the content. So here we are on the first page, and we're going to learn about a bunch of different stuff in this unit. And this is, once again, I talk about kind of like fundamental programming concepts, and I think I've reinforced this with you guys a few times. So I apologize for the reiteration. But when we solve logical problems in programming, we use three essential techniques. The one is a step-by-step instruction, right? So we've learned how to do that. And then we learn how to make decisions like if statements, for example. So like where you're branching your code depending on what's happening. And then the third and very important structure is what we call repetition. And in this case, we will be looking at looping. Now, looping is the concept that like when you're solving a problem, that sometimes you get to this point in your problem solving where the action that you're taking repeats. So for example, if my problem is mowing the lawn today, which I hopefully will get a chance to do, what's the process for that? Okay, I put gas in the mower, I pull the ripcord, the mower starts. Mine's like self-propelled, so I grab the handle and it pulls me across the lawn. I go all the way across the lawn, I get to the other end and come back, right? And then I repeat that process. I go back and forth until the whole lawn's done. But that step of like walking down and walking back, that's one iteration, one cycle through, and then I keep repeating it until the lawn is done, right? So that's another aspect of problem solving. Now, when we do repetitions in code, there's a reason for it. It doesn't happen accidentally. We're often repeating code because we're working with stuff, either information or data structures that also have repeating components. So for example, why are we talking about arrays and loops? And here, the first thing here is a list. Well, a list is a structure that has a number of different things added to it. So like if I'm shopping, for example, and I make a list, I look at that list and I go, eggs, okay, get the eggs. Milk, go get the milk, right? It's a repetitive process. So often when you're dealing with data structures that hold multiple pieces of information, then a repetitive code structure works really well with it. And this is very common in data processing, by the way. So this is my preface to what we're doing in this particular area. All right, let's go ahead and read through their playground here and pick up on the info they're trying to push upon us. And it says people use lists all the time. You might have a to-do list, a wish list, a music playlist, even a bucket list. And lists are very useful and they're common in coding too. When you learned about strings, you created lists of things in some exercises, and you made lists by joining multiple strings together with the new line character. So if you guys kind of recall that, right, we made a shopping list and then we put eggs on it, new line, tomatoes on it, new line, milk, etc. Right? Got to get M&Ms on that list too, right? All right. So ultimately, it says this code gives you a list that displays nicely on the screen, but there's not much else you can do with it, right? It's true because we've compiled it all into a string. And so technically it's not really a list. When we print it out, it looks like a list, but it's not really a list, in terms of a data structure. It's just text, right? Now they're challenging us and they're saying, think of some other things you might want to do with a list, right? So here's an example. How could you call a function on each member of the list without needing to retype them all? Okay, interesting problem. How do you double check whether you've already put something in a list? Well, like practically we would look at it, right? Did I put eggs on here? Oh yeah, eggs are right there. If your list has grown to hundreds of items, could you easily remove the one that says tomatoes? Maybe, maybe not, right? We got to find it first. But if it's hundreds of items, it makes it a challenge. What if your list isn't made of strings, but of something else, like numbers, right? Or more interestingly, complex objects, because you can do that too. What's the first thing on the list, the last thing on the list, the 24th thing, or the 99th thing? Who's to know, right? Um, and how many things are there altogether? And can we rearrange the list? Right now, if you think about the approach up here, where we're just hard coding what seems like a list into a string object, you cannot perform any of those functions on that bullet list with that hard coded string. It's just not possible. Right. So this is the kind of programming problem that early programmers encountered. And then they're like, well, we need to form really what we call a data structure to hold a bunch of values where we can individually control all the pieces of it. So enter this concept called an array, right? And what they're saying here is this is an abstraction, right? Like an array is really kind of a way to organize information logically, but group it together so you can refer to it collectively and then be able to manipulate its contents on an individual basis, like with all the things on that bullet list up there. Now, what I always like to do is when I'm teaching coding and I start to talk about these concepts of lists and arrays, I usually bring up a spreadsheet to kind of demonstrate the concept. So I'm going to do that because I do think this is pretty important, and it really helps to conceptualize what these structures are like when you've never encountered this before. The other thing that helped me is, both kind of in teaching and really deepening my knowledge on it. Like I was always struggling with like, how do I convey this like concept? I get it, but how do I convey it to somebody who doesn't, and really have it be clear, so I came up with this approach. So I hope you guys follow along with my stream of consciousness here, and I'm going to build full example here. I'm going to do a little bit of like spreadsheet kind of trickery or manipulation, if you will, just to kind of highlight the concepts. And you can see I'm like merging some cells, and then I'm like putting borders around them. This is all on purpose, by the way. And if you were in my maybe my Python class, you might get a healthy dose of this also, by the way. But really any class where I first teach the concept of either an array or a list. Okay. So normally, and I use that word cautiously, when we are dealing with either a variable or a constant, right? How do we deal with those? Normally, we give the object a name. So let's say like we're setting up a variable or a constant that is for first name. So I might name the object like this, first name. And then that's just an identifier for what value it holds. And the bottom part of the box is what the value is. So like first name, I'll just put in my name. And really it's a string. So I would like, and really I should probably slide this down one row, right? So it matches up with the other. So here's the name of the object. Here's the value inside of it, right? And with a regular variable, you put one thing in there. And if I'm creating a list, of course, the list in this format would be like, put in a new line character, then let's put in, milk, et cetera, to make your list. And that's not really a list, it's just a long string. Okay, that's kind of the general takeaway. When we start looking at a more complicated data structure, and an array is a kind of like the classic first one we learn, we can actually take a data structure and use it to hold multiple values, but refer to it with one name. And this is where it gets kind of weird. So for example, if I had, you want to think of it as a variable or a constant, that's fine. But if I have an array that contains my shopping, not shopping, but shopping, and I might name it this, and then that structure also has some spots to store information. And then I start adding my items like eggs. And we may as well like populate the whole thing, right? sugar, something like that, right? Really, it should be M&Ms, 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 something like that. All right, but so here's a shopping list. Now look at the difference in terms of the format of this. First, we have one named object that holds all the values, yet all the values are separate, and each one of them is in its own container. And if I wanted, for example, to look at my shopping list, and I didn't mean to scroll like that. If I want to look at my shopping list and look at one item on the shopping list, I can refer to it by what we call the index value. So name of the array, index, and then the actual value that it holds. So you can see maybe the advantage of this, right? So if I want to look at my list and say, you know what, hey, is sandwich meat on my list? No, it's not. So then I could add a position in the structure and put that on the list. If I then maybe look in my fridge and go, you know what, we don't need butter. I got a big tub of margarine, or I got some sticks in the freezer, and I could remove an item, right? And it doesn't disturb the other pieces, right? The other thing I can do is I can look at the structure and pull individual values out, or I could sort them alphabetically or whatever, right? I could do all sorts of things with it just because all the values are separated. Now, if I want to extract a value from this structure, I would refer to it usually like this in most languages, by the way. You'd say shopping list, and then you use square brackets, and I refer to the position of the index number. So if I put in like a 1, for example, what that actually equals is, so that's kind of how we think of an array or a list, right? And so I use both terms, and here's why I use both terms. Classically in programming, this is called an array. However, in some modern languages, Swift and Python, most notably, they do call array structures very often lists. And yes, Java has arrays and it has lists, but they're kind of treated differently, but they're kind of functionally the same, right? At the same time. The whole concept is one named object, multiple possible values, and a bunch of methods that go with it to help control those complicated objects. However, when we write code to deal with, like, okay, print the shopping list, the print command would have to go to the array. And what does it print? Position 0, position 1, 2, 3, or 4? Well, we want to print all of them, right? And that would be a repetitive process to print all of them. So that's why we see arrays and loops often paired together in content. So I think that's a really important takeaway. The other important takeaway here is, like, when we are using index values and they're numeric, you should always note that the computer always starts counting at the number 0, not at the number 1. So the first position is position 0. The second position is position 1, right? So that numbering will always be off, right? But that's something you can adjust for. All right. So this is kind of like the grand overview of what an array looks like, at least in terms of a data structure and the best visual representation I can really make of it. And for me, thinking of an array like in this format helped me really latch onto the concept very strongly. So I'm hoping that it does the same for you, right? It's one named object, individual positions for index values, and then the content. All of it is individually controllable, sortable, switchable, deletable, appendable. So you can add stuff to it, remove stuff from it, all sorts of stuff. So very useful in programming. And the one that I'm showing you here is very primitive in that we're storing strings in this one, but it's also possible to store numbers. It's also possible, and this is where it gets deep, folks, to store complicated objects inside those positions. So you can have, for example, an array of arrays, or arrays of objects, or arrays of, like, who knows, right? Like all sorts of really weird stuff. And I think that's kind of cool. The other ramp up that you'll see eventually is that you know, there is a different way to index arrays. A different way to index it is what we call an associative array, where the index values are replaced with keys, you know, so like, you know, for example, you know, maybe the key is name and the value is eggs. That's not really a good example, but we'll see that later on down the road. I'm giving you guys all like a preface and a preview of this. So now when we go through this material, I think it will land a little bit stronger than if I didn't do this. So hopefully, hopefully you appreciate that. If not, sorry for the long, boring introduction to arrays. All right. So now as we read this paragraph, you guys will come at it with a different mindset. So let's read this paragraph again. It says in Swift, a list is called an array. It's an important data abstraction. In other words, a way to think about a concept such as a list as a unit, right? As one named object without having to think about all its individual parts. Arrays, like all data abstractions, help you simplify your code by providing solutions for all the dilemmas above. So all the things that they list here, why do we put them in arrays? Because arrays allow us via their methods that are available to control the arrays in those capacities. So now they're having you think about this. Think of any iOS app you ever used where you've scrolled through a list of things. That app is almost certainly using an array or a similar structure to that, but it's an array-like structure. Right? So let's go on to the next one. Now, if we actually want to declare an array, and so they give us an example here, where they're creating as a constant, right? So, and you can do that with arrays, a array that's literally filled with values. Now, if I was to take, for example, this, and I'm going to go back over to my spreadsheet here, you know, and I'm just going to paste this in here so I have it handy. This declaration is really kind of the same as saying devices. And then here, for example, would be iPhone, and then iPad, and then iPod, and then Mac, etc. Right? And so we are literally creating this with code, meaning the positions are populated with the actual data that position contains. Just like when we create a literal string, like we literally put a string in a constant or a variable, here we're literally creating an array of strings that are going into that constant or variable, which holds an array. Now, interestingly, when you declare it, I mean, this doesn't look any different from a variable in terms of how we're declaring it, right? But it holds a more complicated object. Notice the square brackets. That's standard when we declare array. So it opens and closes with square brackets. Each individual item in the array is separated by a comma, right? So if we were to look at the position values here, and we're going to be doing this in just a minute, this would be position 0, position 1, position 2, position 3. How many items are there? 4. What's the last position? Position 3, right? Which is the 4th position. You know, that's where, you know, the numbering is a little weird. It says hover over the list in the results sidebar. I'm doing that. It's not doing anything. All right. And use the rectangular show result button. Oh, I see. Yeah, this, right. And to add the array inline to the playground. So now you see how it like kind of defines it. It recognizes it as an array. Notice that, you know, in the formal declaration, it has these like weird brackets here to tell you it's an array of string items, and it's got 4 elements, and that all happens automatically. And I think that's kind of neat, right? That's all there for you to look at. It says change the order or number of items in the devices array little above, and notice how that results. You know, and notice that the order of the items in the results view always matches the order they're in the literal. So, for example, if I, you know, cut this one, you know, and put it back here, and then maybe here I add something else, you know, Chromebook or something. Notice how that changes, but the order is preserved, right? Like the order that they're declared is the order that they go in. So it literally is this array if you could look at it. All right. It says create a new constant named high scores below and assign it an array containing a list of 10 numbers. So let's do that. Now they do prefer that we use let, so let's do that. And we're going to say high scores equal in our square brackets. I did curlies, but square brackets, same key, right? Then let's put in a list of 10 numbers. And I don't want you to put double quotes around them. I want you to type them in as numbers. So maybe you can imagine all your excellent test scores that you take, when you're here at Gateway. So, so I got a 99, I got a 98, I got a 88. That's not so great. I got a 100 because I'm awesome. I got a 77 because I'm working on it. And the point is basically you're just creating a list, and you can go on and on with that. But notice in the sidebar how it is taking those 7 elements as numbers. So we can create arrays with text. We can create arrays with numbers. And I want you to notice here, it recognized that I was putting in integer values and it did figure out the type automatically. So if I were to put in decimal values, then that type would happen automatically. It is possible, and I'm just putting it out there, that you can declare the data format for the array and then populate it with values. Or you can just populate it with values and it automatically reads it and sets it to the right type. If I were, and this is kind of an experiment, if I was to change one of these values to a floating point number, notice how the data type automatically changes. Now all of them are floating point numbers because it has to be to accommodate for that one change. And I think that's an important takeaway. This happens automatically with Swift. However, you can hard code it to force it to be a data type. Let's move on to the indices. All right. So going back to the iPad, iPhone example here, kind of the same one we were seeing on the previous page. And they want us to click the show result button. So I guess that's the show result button to show it. And they're also kind of pointing out, like what I did on the spreadsheet, the values for the indices for each of the items, right? And so now you're seeing why I did the spreadsheet thing first. Now, like when you hit this, it's like, oh, that's what you mean. Okay, got it, right? I'm hoping, right? But because iPhone is first, we start at position 0, iPad's in position 1, iPod's in position 2, and Mac is in position 3. There are 4 items. It even says so right here, 4 items, right? But the index values are 0 to 3. Always remember that, right? This is true in every programming language, by the way. All arrays, index numbers start with 0. All right, let's see what else it says here. All right, so they're making the point here. It's the index number. Okay, we talked about that. In this case, iPod is at index 2, right? iPod index 2, which is the 3rd position. And it always will throw you off, by the way. So we can, go in here, right, and extract the values. And remember, like the technique I showed you on the spreadsheet, like if I'm looking to see what's in the devices array at position 0, it's iPhone. So if you're going to experiment, right, you can just type in a different index value just to prove if I put in position 2, it does pull back the iPod. And of course, you can experiment with that to your heart's content. The next thing here is it says declare a constant favorite device and set its value to iPod by using an index into the devices array. Now, I guess we kind of did that, right? All right. But let's do what they're saying. So they're saying I can set up a variable or a constant. And remember, with Swift, you always prefer constants whenever possible. And I'm going to name it just the way they said. I'm going to say my favorite device equals devices position 2 or index value 2. And what did I do wrong here? I misspelled this, by the way. That's why I'm getting a little error. Right. And then you can see what it's doing here is it's going up to the array definition above. It's finding the item in position 2, which is the third position. It's pulling it back and storing it in this variable. And I can prove that it's in there, of course, by printing. So I could say print favorite device. And then, of course, you will see that it is the iPod. Right. So I can pull stuff out of an array. I can store it somewhere else and then use it for further programmatic, intervention or code or whatever. All right. It says getting a value using the index has to be done carefully. If you ask for an item that is not on the list, you can cause a program error, right? So this is kind of weird too. It would be like telling someone to walk 100 feet down a dock that's only 50 feet long. So I like that. I like that analogy. Like, take 100-foot walk on a 50-foot long pier. That you would do maybe to your enemies, not your friends. And if the person followed your instructions as strictly as a program executes your code, they end up walking right into the water, of course. So now they're saying, try to get the item at index position 4. So for example, I just type devices position 4. That would be, not 54, but 4. And then I want to, mostly this is so you can see what error message occurs when you're beyond the scope of your structure. So there is no position 4. Just remember 0, 1, 2, 3. There's 4 items, but there's no position 4. And it says execution was interrupted. Reason, breakpoint, code 1, subcode. Yeah, that's not a really very clear message. Like this isn't. But if you look down here in the console, Swift contiguous array buffer, fatal error, index out of range. That is a more common error message, by the way, in all other languages too. So an out of range error means like, hey, you're asking for something we don't have, right? Now, if I expanded the array, let's show you here. I'll throw a PC on the Mac list here. So now I do have a position 4, right? It's not shown here, but I do have a position 4. And notice how the error message now goes away. Okay, so that would put it back in range. If I then change this number again, and let's just say, hey, let's try position 48, right? Once again, out of range. It doesn't exist. So what that's showing you is a couple different things. So it's showing you that as we work with these data structures, that there are internal mechanisms that are kind of tracking it and keeping it all kind of together and indexed. All right. Another feature of working with arrays is the fact that we can use some of the methods that are built in. And if you guys remember, I talk about methods and functions and properties. And I guess actually count in this format, like if you see it down here, would this be a method or a property?
That would be a property.
It would be a property by definition. But let's just take, for example, the array that they're showing here. And this array shows basically vacuuming, dusting, laundry, feed the dragons, right? And those are the chores you have at the house. And in my house, the dragons would be the cats, probably, because we have multiple. So, and the next thing says each chore takes you 10 minutes to complete. So you can set up a variable for that. How can you find out how long all of your chores are going to take? So you need to know how many chores are on the list, and then you can find out how many there are by doing a count. Because like maybe your list is really short like this, and you can look at it and go, okay, I got 4 things. But what if it was like tons and tons of chores? Like probably my wife's to-do list as soon as I get done teaching will be probably tons and tons of stuff to do. Well, without actually going in there and looking at the object and printing it and then manually counting, cumbersome, right? We use this property, which is possible when we're working with these data structures called count. So we just take the name of the object that holds all the values, tell it to count, and then we're storing it here. And what's the count for, right? If I add a task like, mow the lawn, see the count go up to 5. Now, of course, given the fact that the minutes per chore are 10 and we have 5 chores, then it's 50 minutes, right? And you can see you can do math with those values too. Always preferring to store everything in a constant. Any questions on that? You guys cool?
I'm good.
Nope.
Okay.
Good.
Thank you. All right, let's move on to the next page. All right. So we have played with this little aspect already a little bit, but now they're starting to look at the types, so like we've learned, what the main, data types are in Swift, right? And the primary ones that we're working with so far have been strings, integers, and doubles, right? And it says really what it's trying to point out is this. It says, of course, array is a type. So an array is actually a new type of data structure, right? So like this, so therefore a string is a data structure too, that actually is very similar to an array, because we learned that like strings have individual characters, kind of like an array does, right? We've done this already. And so when you start thinking about it as a data type, it gives you a different perspective on it. Okay, here what they're asking us to do is option click the 2 arrays below and look at their types. So hold on your option key, and then you can click and notice how it recognizes that it's a string, or recognizes it's an integer, right? And then just by looking at it, if it's a literal array like these are, you can tell by the square brackets that it's an array. One caution: when you guys move over to Python as a language, Python calls this a list, so same thing though, right? All right, so I think that this is kind of interesting, because they say here you can translate the type signature some type into an English sentence by saying this array is a collection of some type instances. If you option click the name and saw instrument, for example, you could say this array is a collection of instrument instances. So in other words, what they're really trying to say is this is an array of strings, this is an array of integers. If they were some other more complicated object, then it would be this is an array of whatever that is, maybe an array of arrays. It will all depend, right? So this exercise says, what is the type of grades, and what is the type of star ratings? Okay, so let's think about this here for a second. What is this referring to? Well, this is referring to this object and to position 0, which is the letter A, right?
Mhm.
What is the type? String.
The string.
And you can check it. Okay, the point is you can check it, right? What is the star rating in position
It's
0? It's
integer.
number 1.
Should be an integer.
Yep, it is an integer, right? But I think it's kind of neat that you can confirm that. So like this little option click trick is kind of handy. So like if you're looking at code and maybe your array structure is defined like 500 lines up, the last thing you want to do is like scroll to find it and go, where is it? Or even if you do a control F to find, it's still kind of cumbersome. And then you have to jump back to where you were, when you can just hover, option click, and get your data type. And that's important, because depending on the data type, you will have different types of features, properties, and methods that go with it. So that's why that's kind of key. It says, since arrays always know what kind of element they're holding, you can pull out a single element from that collection and rely on type inference to establish that some grade is a string and some rating is an integer. So we just proved that. It says, try setting another grade to a number, what happens? So how would we even do that? How would I set this to a number?
Wouldn't you need another string for grades?
Well, first let's look at what this is referring to. Maybe that's a better way to start. Right. So
Yeah.
what is this referring to? It's referring to the first position, actually the second position, which is position 1, right? So that's the letter B. But what if I change this to a number? Can I do that?
No, because it's
No.
mixing types.
Yeah, I'm mixing types. Basically, the point of this is it doesn't like it.
Mhm.
So arrays in Swift, like in most, we'll call it strongly typed languages like Java or C or something like that, don't allow you to mix types. Real interestingly and very confusingly, in Python, it is allowed. Python doesn't care. Swift does, and that's a really big difference, by the way. Let's go through the next screen here. All right, this next thing says when you group similar values into a collection, it's usually because you want to do some work on each item. And then when we step through that collection of information, it's called iteration, right? So here's like some heavy terminology here. And so when I say the word iterate, and I say that to a student, usually I get blank stare. Real frank, like they've never heard that word before. Now I might say to them, reiterate, and a lot of us already know what that means. Reiterate means to repeat, right? So like if I'm like repeating myself, I'm reiterating. But re is a prefix and iterate is the actual root word. So to look at one object in an array is to iterate once. So if I looked at just name, I'm iterating. If I look at the next one, I'm reiterating. But every time I look at something in an array and I step through it, I'm doing iteration, right? So that word is tied in with looping, which is where we're heading. So it says now you can define a function to process each array item. Right, so for example, the function's called invite. It's expecting a parameter called friend, which is a string. And then we're using string interpolation to output it. And this is kind of weird, right? Because the function, and you notice, when we do the show code button here, it says, hey, friend, please come to my party on Friday. Okay, now we don't know what friend is because that hasn't really been set. And why is it saying 3 times here? It's kind of like the weird thing. How is it saying, hey, name 3, please come to my party on Friday? So what is it really doing?
Just trying to pull the name from the list of friends,
Yeah, is it though? I'm questioning, is it?
or it's possibly saying like the same repeated message over and over and over again.
Yeah.
So
I mean,
yeah,
where are we where
so
are we
that's
reading it
wouldn't that
from?
just be? So wouldn't that just be giving you just like wouldn't that just be giving you like an integer return?
Yeah, this is a really good question. It's very unclear what it's doing.
Yeah.
Right. So if I actually, the reason it's running 3 times and you guys aren't looking down here is what's happening, right? Because the function is getting called 3 times. So notice how it's getting called. They're calling the function, they're passing in the parameter, and they're declaring that we're pulling it out of the array at this certain position, feeding it into the function, and yeah, 3 times it happens. Okay, and now notice what it says here. This code works, but it leaves you with a few problems, right? It says you need to know how many things are in the array so you know when to stop calling the function, right? So in other words, if I want to pump all of the names in, right? Well, this is only going 3 times. and it's only hitting the first three positions. Whoa, what about the other two? Why did they stop at two? Why did they stop at this position, which is named 3, as opposed to doing the others, right?
Yeah, why did it?
There's no clear
Why didn't
indication.
they? Yeah, why? Like, I guess I'm failing to see how that function there would make it stop at 3 when there's no really like declaration on there's no reference to index, and if there wasn't a reference to index, wouldn't it just cycle through all of them?
Right. And
Or
really,
not at all?
here's what's happening, right? It's not automatically hitting all of them, because here we are manually running each time that it's calling a statement. So it means
Oh, okay, I see.
you see what I mean?
Okay.
We're calling it 3 times. So if I wanted it to hit the other object, I basically would
Yeah.
have to
Okay.
grab this
I'm
code.
looking at that as like that's the output, but okay, never mind.
Yeah,
I see
right.
what's
And
going on
Jonathan,
now.
you're starting to see the picture now a little bit. So if I
Yeah.
add this one, it's going to do it. And if I add one more, it's going to do it. But it's only happening because I'm telling it to. I'm doing a sequential approach to making it happen, right? And then of course, if I add one more here, because I'm like, oh yeah, sure, there's got to be a 5 also, right? Well, then we start getting out of range, right? And it starts to break. So we don't want to do that, but it's only running the number of times that it's running because we are step by step telling it to do that. Okay, it works, but it's very inefficient code because now I'm basically reiterating my statement 5 times in order to make it do what I want. But functionally, it is the same statement attached to the same object. I just want to push through it. All right. So here's the whole thing. Is there a way that we can do this better? And yes, there's this thing called loops, right? So here we got now finally introduced to this concept of the repetition of code. So rather than retyping each programmatic step that we want it to execute, we can write one statement that does all of it automatically. Now, in the case, and I want you to think about this really carefully, because here, we're not dealing with a lot of objects. We have 5 objects here, and it's not that big of a deal to do what I just did, which is to copy paste, 3, 4, 5 times. Not a big deal. Change the number. Took me like 30 seconds. Not a problem. But what if that array had 10,000 items in it? Yeah. Now we're starting to go, oh, I'm going to spend a whole day like copy pasting this stuff, right? And tweaking numbers. Makes 0 sense, right? So this is why programmers come up with this stuff, by the way, because then they go, well, there's got to be a way I can shortcut this, right? So let's read what they have here, and then we'll get down to the code. It says Swift has a built-in way to let you run code for each item in an array. It's called looping or iterating. Think of it like a roller coaster that seats one person. The queue or the line for the roller coaster is the array. The car arrives, the first person in line gets in the car, they do the circuit, and they come back, they get off, the next person goes in and they do it again, right? And so this is kind of what we're going to do with code. We're going to write code. We only need one snippet of code that does the action. You read the information and put it on the screen. And then that repeats for each additional piece of information. And so what we do is let's take a look at the array. So same array, right? The friends array. And then we start with our first type of loop here. And usually this is the preferred loop of most programmers, by the way, called the for loop, right? And the keyword is for. And we're saying, what are we looping through? We're looping through the array named friends. And then this portion of the for loop is basically saying, we're coming up with a variable name for each individual item generically inside the list of friends. So if the array is friends plural, each individual position is a singular friend. Right? And this is a really common kind of syntax. By the way, we use the same exact syntax in Python. So this transfers over to Python beautifully. So Jomar, when you get to the Python class and IT scripting, you're going to be all ready for this stuff and you'll be like, got this, you know, hopefully like, that'll be your mindset. Or maybe it'll be more like, oh, we kind of did that in the Swift class, you know. When you do a for loop, by the way, in Java or C#, it does not work like this. The syntax is very, very different. But I love this syntax because it's so simplistic. You see the color coding matches up. So this is the array. This is an individual item in the array. So we're saying for each individual item in the array, right? So for each friend in the list of friends or array of friends, we will go through. First, we set up sparkly friends. So we put these little like emojis there and we feed their name in. And then we print, hey, sparkly friend, please come to my party on Friday. How long does that operate? This is the beauty of this type of loop. It automatically steps through each value. How many times? 5 times, and executes the code inside. And then when it's all done, it will output it at the bottom. So when we look at the output down here, because there's a print statement in there, hey, you know, and you can put real people's names in here if you want to play with it. But we go name 2, name 3, name 4, name 5, automatically step through the entire structure. And then get, you know, once it was done, moved on to the next step. Since these steps are always the same, we repeat them, right? Otherwise, our technique would be, you know, if it was a singular function, so just go back to this page, we'd have to call that function over and over and over again, or you would take these 2 lines of code and just over and over and over run them again, right? Makes no sense. So when we have a small list like this, you're like, okay, well, whatever. How much time did it really save us? Once again, I'll throw the scenario at you. What if instead of 5 names, it's 50,000, right? The beauty of this piece of code, this function, is it would handle all 50,000, no problem. You know, and if you want to experiment with this, and you can do this in the playground if you want, you can go out to the internet and just search for like array of names, like huge name of array of names, and just paste it in here and let it process. It'll take a few seconds, but it will work. And it will put it on the screen, and then you'll see exactly what the time savings is, because it saved you this thought of like, okay, well, if I know in advance how big the list is, I guess I could get a count and then paste the command in 50,000 times. And then you have 50,000 lines of code when you can cover it with 2, you know? So that's why we create loops. So this is, you know, kind of like going back to the example I used for mowing the lawn. You know, I have some step-by-step steps, and then I get to mowing the lawn, and that's repetitive. It's like, go down, turn around, come back, go down, turn around, come back. Do I really have to say that step over and over again? No, you just go down and come back until you're done. That's kind of what this loop is doing. This is a loop that operates automatically, and you can see it's very, very powerful. When we start applying loops to data structures, this is kind of the heart of data processing, you guys. You know, like when we pull in large pools of data, it's often for loops that process the data, and it's often array structures or similar structures that hold the data to be processed. And very, very important for all of programming, no matter what you do. Right. So I think I explained everything that they're saying here, but let's look at their experiment. And it says, the friend constant was defined as part of the for loop. What do you think will happen if you uncomment the line below? Will the result be the same as the loop used, or will it return an error? What do you guys think?
I say error.
All right. Of course, you can try it on your own and then just give me the answer, right? But yeah, that's what will happen, because it is declared, right? And notice the error message says cannot find friend in scope. The only place that this is valid is inside this function. So really what this is saying is this is a variable that will change. It will match the data type of this array, and its only usage is within these curly brackets and the definition of the function, but it's only in scope right here, meaning this is the only place it's valid. If I had
Mhm.
declared it outside, then I wouldn't be able to use it in this fashion in the for loop. And that, you know, kind of the takeaway. So yeah, that returns an error. Why don't we do this? Let's take a 5-minute break. I'm going to remember to pause my video here if I can. Right, and you guys know I've been struggling with this, so I'm going to be really like methodical about this. And please, all right, we're back from our break, and we're going to move on to the next page. So we're going to talk about mutable arrays next. And it's kind of interesting because they're using this word mutable, and this is another one of those like weird terminology things that you hear in programming quite a bit. Because basically we use the word in both of its meanings. So we have mutable and immutable. And that's probably the word you tend to hear more often, kind of like reiteration. Also, you hear like the alternate version of it more than the regular version of it. But when we look at that word immutable, what does that word mean? We sometimes say like God is immutable, you know, that kind of
Can't
thing.
change it.
Yeah, you can't change it. That's what it means. So when we have a mutable array, therefore it implies that we can change it. So in other words, you know, we were starting to look at arrays and we were using the let keyword, which of course in Swift is the constant declaration, but there's no reason why you have to make it immutable. In fact, you can just switch the keyword to var, right? And then you'll notice how here we define it as transit options as walk, bus, bike, and drive. And then down here, because it's a var, we can just reset it and say rowboat, paddleboard, submarine. And heck, let's be funny about it and say spaceship to complete our transport mechanisms for the future. Apparently. But it says, notice it says, but you can't change the type of items that an array holds. So I can change what's in the array as long as I stick with the type. So in other words, I can put a string here, but I couldn't have added a number, right? And we've tried this before too on previous pages. So that gives us this option. So here they're trying to demonstrate, of course, if you do try to force numbers into something that holds strings, well, now you can watch the errors fly, right? And it takes a little second for the playground to process it, but you saw the console down below immediately responded. And then, you know, the in-page debugger or whatever is highlighting it. And notice the little red squiggles. And, you know, the other interesting factor here is when you are like working with these little red squiggles, and it doesn't work so well here, but if you're in Xcode proper, you can actually hover over those and get the error messages kind of on the fly, real localized. All right, let's move on to the next page here because they're about to show us kind of more of the formal ways of adding stuff to arrays using some of the methods and things that are built into those structures. Right. All right, so we basically said earlier, right, that when we hard code an array or literal array, we are literally putting a string in it. And here they're kind of showing us a different approach. And the data type is basically inferred from its content. So as long as I keep putting strings in there, Swift is smart enough to say, hey, this is a string. Look, you got all strings in here. Your data type must be a string, right? And that's great as long as you know what you're putting in there. But what if, right? You're writing a computer program and you're creating an app or something, and maybe the app is going to allow your user to generate their own shopping list for the grocery store, right? You don't know what's going to go on that list. So it is also possible to declare an array as an empty object using this syntax here. So what we're doing is we're setting up a variable, which is a list. It will hold an array. We're indicating what the data type is. And notice how we put it in square brackets. So we're saying, really how this reads is create an array of type string, right? And then the empty parentheses, and the empty parentheses are telling us that there's a constructor function somewhere in in the libraries that will build this structure. It will make it empty. Once again, go back to my spreadsheet example. It's just building one that has nothing in it. And there's nothing in any of the positions, but it's ready to receive it as soon as you're ready to put stuff in. All right, so now that we've created it and it's empty, how do we add stuff? Well, there is an append method that allows us to basically add the dot syntax. We say dot append parentheses, and whatever's inside those parentheses will then get added to the array structure. And if you pull the little sidebar over and you see it, you can see that we're building it. So with the next command we're going to learn is insert. Now, what append does generally, so we're going to look at like different forms of adding stuff to an array here. Append will add the item to the end, and I'm going to demonstrate this because I think this is important, and I think they do cover it later. But if I use the append command and then I throw in, okay, I keep talking about M&Ms. I must be creating some or something. I can put that in there, right? And now you can see in the sidebar, it's added, but it's added to the end of the array. Now notice the next command, insert. And this is kind of an interesting command because it has two parameters. So we're not only feeding in what string we're adding, but what position we're adding it to. So where are we adding kumquat? To position 0. If I were to copy this command, and I think in the experiment they make us do this stuff, by the way, but I'm of course rushing to show. I can then insert. Are we doing fruits or weird foods, or how about we're going to insert pizza? And notice how it's telling me, like, in other languages we can kind of use that command alone, but if this one doesn't allow that, we have to tell it what position we're going to and what the index value. So we're going to insert it at which position. Well, we know we have 3 things in the array right now, so it's going to have to be either position 1, 2, or 3. Why don't we do position 1? Let's see the result. So watch the output here. So inserting at position 1, which is the second position, pizza. And yeah, it's lowercase, but you see how it works. Here's another kind of weird feature. You can use this this shortcut operator, the plus equals, to also add a whole array to your array. And that's kind of neat. So it's kind of like you're concatenating arrays. So look at the result of that one. So we're adding strawberry, plum, and watermelon to our current list of kumquat, pizza, banana, and M&Ms. What a wonderful combo. But see how those are just appended right to the end. Of course, you can experiment with that one too. So if I want to say list plus equals, those are curly brackets, sorry. What do we put inside there? I don't know, whatever. And doesn't matter what it is, but you can see that they are getting added to the end there, right? Like if you see that they're being added. And so it's saying practice adding items to the list using each of the 3 methods. Well, we kind of did that already. So if you guys did these experiments, there you go, you're all set. But you can keep experimenting. And I think this is pretty fascinating that we have basically 3 different unique ways to add stuff.
And
by the way, yes, go ahead.
Can you insert an array? Like, can you add, like, so your list plus equals an array? Can you do that same function as adding an array at a certain index? Like, say you wanted to insert an array in the middle of an array, perhaps?
All right. You know what, Jonathan? Here's how I would generally figure that out. I'm not answering that one off the top of my head because I think the answer is yes, but I'm not sure of the methodology. So I'm going to just create, my array, right? And let's just create it one and try it. I mean, that's kind of a clever way to do it. Like,
Yeah.
hi. Right, so I'm just adding a couple words. That's no problem there. But then we can also do list dot insert. And what are we inserting? And it says new.
Would it be my array dot insert?
No, at this point, we're trying to take my array and insert.
Oh, and insert it, yeah,
list, right?
yeah.
So let's see if we can just use that. I don't know if it will let it happen. It looks like it's letting it happen. At what position? I don't know, 0. Does it work? Yeah, it doesn't like it.
Oh, okay.
Okay, so, all right, so it seems like there is a way to do it though, because notice like the compiler error on this says missing argument label content of. So they
Interesting.
have a keyword that you can use to make it happen. So this is how you make it happen then. And basically it works like this. So contents, oops, contents. I think that'll work.
Oh, look at that.
Yeah, check it out. You just have to know. And see, this is the nice thing. The compiler was actually pretty clear in telling me how to do it too. But it's like, oh, you're trying to put one array in the other. Here's how. All right.
That's cool.
This is extraneous knowledge and kind of like a little bit higher level, but yeah, that's totally possible. Yeah, why, you know, think about it, why wouldn't it be? You know, I mean, why would you create this and not have that capability? It says, all of these list methods are abstractions for a series of instructions for doing useful tasks. So following Swift syntax rules, right? Now move on to find out how to remove items from an array because that's useful too, right? This time we're working with numbers though, and I'm going to pull a panel over so we can just see those real clearly. So we start with a list, right? And it is mutable because it's a var, right? So we can change it. And our list is just 0 through 4, right? It matches up with the index numbers. So we can actually use the remove method. So here's like, let some number equal numbers dot remove at 2. So it goes in, looks at position 2. So 0, 1, 2. It happens to be the number 2. And then remove it at that position. And then let's redisplay numbers afterwards so you can see it was indeed removed. Run it again. So let's, you know, for example, do I need to store it? No, I don't necessarily need to store it. But I think the reason they're doing the let here is to show you that it's pulling which number it's pulling. But I could, in principle, I'm trying to get out of there, just say numbers, oops, numbers dot remove at, oops, see, I broke it again, at, I don't know, give me a position here. Let's go position 1. And then just repeat numbers. This is how I would do it in Python, by the way. So now it's going to position 1, which happens to be a 1. And now that's gone. So I don't have to store it. They, you know, I'm not really sure why they did storing here, but the method works without, right? You don't have to store the output of it. If you're going to use the value, yeah, you should store it. There's a couple of other little methods they have built in too, is we can also run the remove first command, and you can see it's like ramping up on the stuff I've already done, so I'm kind of really messing it up. Right. So I should probably comment these out. All right, so their examples don't all break. But here, when we remove the first, right? What was the first? It was 0. That's now gone down here. If we use remove last, also pretty intuitive, right? It should remove the 4, and indeed the 4 is gone. I do like that Swift does this, like whatever, and I think this is a byproduct of the let once again. Why are they doing the let? So you can see the value and retain it. Because if you are removing something, doesn't necessarily mean you don't want to store it. Right. Right. There's also a remove all command. So let's say you go shopping, right? And you bought everything on the list and you want to use the app again. There you go. You just remove all from the list. It's a new day. Let's form a new list, a new shopping list. Right, so that's an example of that. So we have the remove command at a particular position, remove the first, remove the last, and remove all. Okay, so we can tunnel into specific items. We can generically select stuff depending on what's in there. And then we can clear it all out. And I think all of those are useful. It depends on what, functions you're using, obviously. All right, let's see how to replace items now. And this is kind of an interesting thought too, because just because you're removing something from the list. So for example, maybe I'm shopping and I have like milk on the list, and I go to the cooler and there's no milk in the cooler. So now I might change my list to put in almond milk or oat milk or whatever the latest alt milk du jour is. So I want to replace the item. Here we're looking at flavors of ice cream. And what they're doing here is they're reading, right, the first value, and they're storing it. So we're looking at what's in position 0. It's chocolate. Right? This we've already learned, right? But if I just have a statement here where I'm referring to that particular position in the array and just give it a different value, right? And I don't know why they're doing it exactly like this, because my brain operates like this. I would just do flavors. Now you will notice when the list pops up, fudge ripple is now in the place of chocolate, right? And I could ramp that up a little further. I could say flavors. Let's say position 1 is, I don't know if this one's on the list. It's not, butter pecan. Now you can watch that change on the list too, but to see it, you have to call the list or the array, excuse me. So you can see the change, right? I'm guessing that these are the exercises below too. And then, they keep assigning stuff, I don't know why they're going to that trouble, but I think they're just trying to reinforce this thing. It's like store stuff in constants. From a practical standpoint, we can make the maneuver, just make it display, and it will display, right? At least in the playground. There's no output here, but in terms of seeing, what's in there, I think this is a helpful approach. Right. So it says change the value of pistachio to a flavor of ice cream that's not already used in the array, like mint chocolate chip. All right. So where is pistachio in the list? This is position 0, 1, 2, 3. So to change it, pistachio, to something else, we are going to say flavors, position 3, now equals chocolate chip. Flavor I despise. By the way, give you guys care, right? Mint and chocolate should not go together. I'm sorry, they just don't. My daughter loves it. I completely hate it. Means I don't like Andy's mints, pretty much, right?
Yeah, I guess not.
Yeah, I guess not. But you see the point here, right? Like it's possible as long as you declare the array as a variable, you can go in there and change its contents. And very specifically, you can drop stuff right into very specific positions. Let's kind of do a wrap up here on this particular unit and see if we understand all the concepts. So items in the array are all of the same type. So this is a Swift rule and very, very common in most languages. There are some languages that have exceptions to this though, so be careful of that. The items in the array are in a specific order. So an array is ordered by its index numbers, right? The first index of an array is 0, not 1, right? Computers always start counting with 0. Why? Because it's the first single digit number in the base 10 number system. It's 0, not 1. Accessing arrays using the index can be dangerous. If the index is outside the bounds of the array, your program will crash. So you got to be careful of that. So often, if you're going to refer to a particular position number in an array, and I'm just telling you this is a programming practicality, often programmers will run the snippet of code to see how long it is. For example, you can find out the number of items in the array by using the count property, right? So there's the trick, right? To prevent the problem from happening. And says you can use for in loops to safely access each item in array in order without needing to know how many items the array contains. So therefore, the for in loop structure is a really, really useful one, particularly when you don't know the size of the data that you're working with. Really helpful in data processing. Mutable arrays allow you to add, remove, and replace items. That's a good thing. So you got to use the var keyword for that. Immutable arrays, if you use let, it's immutable, it can't change. There are times where that is actually useful. You can combine two data sources by appending one array to another array and then process the array as a single sort. Another really common data processing technique. So I might pull in data from one system, pull in data from a different system, pull something from a database, get some direct entry from a user, combine those all together, and then process it all at once. Right, so that's why these commands exist. All right, so now we do have an exercise here. And so as we kind of do these exercises, and we are going to kind of do this in, let's call it challenge mode, right? So, and what I mean by that is I'm going to pause the recording. I'm going to let you guys work independently and see if you can solve it. And then we'll restart the recording, and then I'll show you how I solve it. And then hopefully, if your code's not right, fix it. If your code's right, fantastic. And your code might be slightly different. It should be fairly close. So let's do this one first. Let's set up the scenario. So the exercise is called count. And it says, if you try to use an index that's outside of the array, your program will crash with a fatal error. How can you make sure that doesn't happen? You can find out the numbers in an array using the count property. Remember, no parentheses after it, just .count. All right, so they give an example. What devices equal iPhone, iPad, iPod, Mac, and then devices count, and it's got 4. Right, there's your given. The only safe indices to use for an array are those less than the count. So if you have a count of 4, the highest array index will be
3.
3, right? It's always 1 less than the count. So this is really standard thing in programming. So here's the exercise. Using what you've learned about making decisions, so if statements, write an if statement that will only access the array if the value of the index is less than the array's count. Uncomment and update the code below, and then update the index constant to different numbers and see the results. All right, so I'm just gonna pause the recording here, folks, and then I'm gonna let you do this. And then when you think you're done, let's take a look. All right, we've been working here for a few minutes trying to figure this one out, and I'm going to show everybody here how I would approach this one. So I'm going to begin by removing the comment marks here, and I know this is going to throw errors, right? We are going to put a statement in here that hopefully will address the issue that they're talking about up here in the exercise description. So they're saying it's only going to access the array if the value of index is less than the array's count. So this is how I would code it. So index on line 15 there is a hard-coded constant. So we're going to say if index is less than, and then the trick is to get the count from the list. The list is called devices, and then I just simply issue the count property here, and that's how I would solve it. And this is basically the solution. And you do have to spell it correctly. So I'm like, hey, this should work, but I'm seeing error messages, and I'm like, I thought I was all clever, but apparently not clever enough to type it correctly. And see how the color coding helps you in this circumstance. So is the count of devices greater than 3, it is. And you could potentially test that, right? So you could take the statement here, for example, and well, actually they're running it up here already, right? So we already see that it's 4, so we know that's going to work. So they kind of really gave you the clue up above. And then it was just a matter of employing it, right? So very common technique, by the way, to run code to check to see what the count is, therefore to get the value of something up until that point, right? If this was 4, for example, it breaks, right? The if statement doesn't run. And certainly if it's like 5, it's not going to run, right? Any number above 3. But as long as it's 3 or below, that will run because we know the count of devices is 4. But we don't run the command, figure out the value. We can just directly issue that property right in place in the code. That's really the takeaway here. You guys good with this one?
Yeah,
Now that you
I was
see
actually
it,
kind of. Oh, sorry.
you want to share your screen?
No, I was gonna say I was actually kind of close to that originally, and then I erased it because I wasn't sure if that was it or not.
Right. It seemed too simple of an answer. Yeah, this was
Yeah.
actually a very, very simple answer. And you do get comfortable with this sort of technique as you kind of move forward with this stuff. So let's go on to the next one and try this one. So this exercise is called the karaoke host. So it says you have a friend who loves singing karaoke with a big group of people. The karaoke singers add songs they like to sing to a list, and the karaoke host calls out the songs one by one. Okay, so your friend has asked you to write software to help manage the song list, of course, right? So they call the coders. Create an empty array to hold the song titles as strings and use the append method to add 3 or 4 songs at one time. Okay, so here's my thought on this one. Let's take these one at a time, and I'm going to use the same technique. I'm going to give you guys a chance to code it. I'm going to pause, and then I will unpause and demonstrate. So let's do that again. So here goes the recording pause right now. All right, we've had a few minutes to work on this first one here. So let's kind of walk through the process. So the first thing they're saying is create an empty array to hold the song titles as strings. Now, okay, so the first question I'll ask is let or var?
var,
Var, why?
because you want it to be mutable.
Yeah, you want it to change, right? All right, so let's just call it song titles. That might be a good thing.
Mhm.
You could also call it the karaoke list or whatever. It doesn't really matter. And then on this side, what we do, if you remember, if we're creating an empty thing, we just use the syntax and then pair of parentheses, which technically is the constructor function, right? So it creates the
Mhm.
empty object for us. So hopefully you got that part right.
Yep.
Then it
I
says
actually,
the append method to add 3 or 4 songs at one at a time. Okay, not at one time, but one at a time. You got to read it carefully, right? Because those words that you're just like superimposing them, it changes the whole meaning. So
Oh,
yeah,
okay.
I don't know if you're catching that, right? So Jonathan,
Yeah,
yeah,
I
you're catching
edited
the
it as
magic. So
yep,
I'm
I
going to do
added an
append,
array to the array.
and we're just gonna have to do the classic nothing but Beatles songs here. Why? Because those are the titles I probably remember the most. You know what? I'm try to let that IntelliSense fill it in for you. I always use these song titles because whenever I do programming classes, those are the 2 songs I use the most, by the way. So oh, let's have some fun with it. Let's put in like, I don't know, player or something just to balance it off. Right. And do one more. But you can see the technique, and then what you should be able to see, and I'm going to show you this in the aftermath. Let's do like maybe want to make sure they made it in. So this is the part, you know, that, so really it's already populated, right? You guys realize that it's already populated. But if we want to see it, then we can just call the object and then it will show it in the sidebar here. So we can actually see the array with the stuff in there. But you notice every time I did an append, it also showed the contents, right? And I mean, you could also in principle do this. You could print song titles. Kind of weird, but that works too. And notice how it prints it. It shows the square brackets and everything, right? So either one of those approaches is fine. I like to do that just to verify, right? Even though, you know, technically the playground sidebar is doing that for us, you know, it doesn't hurt to verify. All right, let's take a look at this person here. Says one enthusiastic singer wants to add 3 songs at once. All right. Create an array holding this one singer song list and use the plus equals operator to append their whole list to the end of the group song list. So once again, kind of the answers are on the previous pages. So make sure, like when I pause the recording here, you guys go back and take a look and copy that approach and see if we can get it to work. I'm going to give you a little bit shorter time frame on this, right? Maybe 3-5 minutes, something like that, and then I'll come right back. So pausing the recording one more time. All right, so we're back from our little break, and let's try to do this next little step here. They're telling us very specifically how to accomplish this, right? So the let's call it the enthusiastic singers list, or is that too long of a variable name? So we'll make that a let, by the way. We'll call it singers list. And then I'm just going to hard code this, right? Is that okay if I do it hard coded? So I don't know. I need song titles. So I'm going to be like, all right. So so for me, I got to think of like a band and then start thinking about what songs they have. So I'm going to do like bands I like, if that's okay with you guys.
Okay.
All right, let's oh gosh, I can't think of a band I like right now. Okay, we'll do Rush. Okay, so this guy wants
There we
to
go. The Holy Trinity.
yeah, Tom Sawyer,
Steel Day.
Barchetta, right, and Hemispheres. Let's totally misspelling everything. And now we want to take that list, right, and append it, right? And how do we do that? Well, we go song titles, right? You gotta spell it right. That's always a thing. And then can I just go right to plus equals?
Yes.
Yes.
And can I just do this?
Mhm.
Okay.
Yeah. And Jomar, you maybe, and I'm just putting it out there, you might be overthinking this one.
I was.
Yeah, and this one is intended to be just as simple.
Yeah. I overthought it. I was very close to that, but I just overthought it.
And that's okay, right? I mean, but now you know for sure.
Yeah.
Yeah. And then tomorrow you'll forget probably, but that's okay.
That's how it usually goes.
Yeah, that's the joy of programming. All right, so we have another one here. It says write a for in loop, and for every song title in the array, print an encouraging announcement to let the singer know that it's their turn. All right, so here's what I'm going to do. With this one, I'm not going to pause the recording. I'm just going to go ahead and code this one, right? So this is kind of our first instance of working with loops, and hopefully your brains are thinking the same way. Now, we already have everything defined, so let's keep that in mind, right? We already have structures in place, and now we have this like longer list here. It says for every song title in the array, print an encouraging announcement to let the next singer know that it's their turn. Okay, so this might be a little bit more of a leap for you guys. That's kind of why I'm stepping in here. So I'm going to say for when you're doing this, right, where are we pulling, what are we pulling from? What structure are we pulling from? We're pulling from song titles.
Mhm.
Right? And a real common thing in programming, by the way, is when we name an array that has multiple things in it to use a name that's plural, right? So a real common thing would be, so if this holds song titles, plural, we should call it song titles, not title, right? So if I'm doing this for loop, it would make sense to just call it for song title in song titles. If you're feeling my drift, but you can actually shorten that. You don't have to do that exactly, but that's what a classic programmer would do. They would do this for song title in song titles. They would run the singular version of the plural version. And actually, did I misspell this? No, this is correct. This is absolutely correct, right? Because I did not misspell it. And then what are we supposed to do? We're supposed to create some sort of a encouraging message. I'm trying to be verbose. Did I spell that right? Encouraging. Yes, that looks pretty right. And the message could be, and I'm not going to use emojis. I hope you guys don't mind. Great job singing. Now I'm going to use string interpolation here. So here comes the parentheses. And what are we going to string interpolate here? The song title, singular. That was fantastic. Even if it totally was not. Right, now notice this happens 7 times. How do I see the output of this? Because I declared a function, or I declared a loop, right? Is this actually outputting it? Are we seeing an output here? Do I need to, we have to print it, right? So you guys might not see this part of it, but we are just going to print the encouraging message. I don't have to type it over and over again, but notice in the console right away. Great job singing She Loves You. Great job singing Blackbird, South of Heaven, Esther Puppets, Tom Sawyer, Red Barchetta, and Hemispheres. That was fantastic. All right. That worked okay for you guys?
Yeah.
Okay. Let's try the next thing. It says after the loop is called everyone up to sing, use the remove all method to clear out the past songs. Okay, so you can see why I'm kind of this one I'm just going to do too. So we're going to call in song titles, and then what?
So after the
Trying to type it really slowly. Yeah, we just issue the remove all method. And notice what happened here is I chose the wrong one because there's a remove, but we want to remove all. All right. Now you can see already in the sidebar that it's all gone, but just in case you want to prove it, you can just type it back and see that it's empty. All right, so that's the solution to the first one. Let's move on to the next exercise. All right. All right, the first thing you will notice is there's a lot of stuff on this page, right? And this is the kind of issues that programmers often face, right? So when we get like short little lists of things, it's like, great, I got piece of cake, no problem, right? I can handle this conceptually. But then you start to process large volumes of data, and it's really overwhelming. When you start thinking about like, oh man, if I have to write individual programming commands to handle each thing inside of this array, I'm going to be here all day, right? And that's not what you want. So let's look at the exercise. You're implementing a poll app for your class. You start with a basic yes, no question counter, and now you have your first batch of answers back parsed into 2 arrays. Now this word parsed, by the way, is a programming term as well, which means to read through the information. That's what it means. Usually text, right? So when we say we are parsing something, it just simply means we're reading through it. right? There's a lot of data, but don't worry too much about the long arrays. Whether you're planning to iterate over 2 items or 2000s, the loop you create will operate exactly the same way. And it's exactly why we do looping. Right. So you can notice here that they set up some constants, a few of them, right? So, and what the question was from the survey or the poll is intrinsic in the name of the constant. So should mascot change votes? So people either voted yes or no, true or false. And here is the collection of all those values. Now it is interesting to note that this is of type Boolean, right? And then they're making a point of showing the data type here. They wouldn't technically need to. You could remove that and it would still work. Swift would pick up the data type automatically. The other question was, should install coffee vending machines? Right? True on that one for sure. Would be my vote. Should have more poll options. Probably false, right? We probably don't want to contend with that if we don't have to, right? So we have these 3 sets of datas, and it says this is too many votes to tally quickly by hand, so you have to write some code to tally it for you. And it says, no, this is also a lot of votes for Swift to use type inference to determine what kind of array it has. The type annotation is written in the array literals above to tell Swift the type of array. This prevents the playground from running slowly. So what they're telling you is when you don't declare the data type for something, your code executes less efficiently. And I want you guys to hear that real clearly. So if you're writing like a really big, powerful app, and you know you're going to process a lot of data points, if you can tell it what kind of data it's just going to work that much faster because it doesn't have to guess each time. All right. So this is a step-by-step process. So the first step is, and I'm going to code this with you by the way, create 2 variables, one to count yes votes and one to count no votes. Each should start off with a value of 0. Right. And let's read the next little part here. It says call out exercise. Create a for in loop that iterates over one of the vote arrays and checks the value of each vote. If the vote is true, the loop should add 1 to the vote yes variable. If it's false, should add 1 to the vote no variable. And it doesn't, and I want you to read this carefully, that iterates over one of the vote arrays. So we don't have to process all of them, just one. Okay, so let's try to do this. We'll first start with creating the variables. So let's create, and they do have to be variables. So we're not using let's here. And I'm going to just call this yes count. Could call it yeses, I suppose, right? Yes count. And we want to preset that to a value of 0. Why? Because we were told to, right? Then we have another one called no count. Also presetting that to a value of 0. Right. Now let's do the for loop. So we're going to say for, okay, we need to process just one of them. I think it's probably easiest to process the first one first. So notice what I'm doing here is I'm just coming up here to copy this because I'm probably going to mistype it. I know the auto fill would do it too. But for me, I'm just going to copy paste it. And I'm also going to keep in mind and I'm going to just use a placeholder right now for whatever in should mascot change votes, right? I'm just setting up the structure. I'm going to change the word whatever, and I'm not really sure what a good thing is. I don't know. I guess I could use the singular format, should mascot change vote, right? That would be very, very verbose. That would probably be the better way to do it. So normally this is what a programmer that follows the convention would do, because they would use this. Now, I want you to think about this. If this is going through every value in that array and looking at each one individually, right? When it processes, and notice, oh, wait a second. Did I type that by mistake or did Swift put that in?
I
missed it.
think Swift did that.
Yeah, I think I might, yeah, I think Swift did that. Did it do it for you guys?
Mm.
All right,
Okay,
let's just take this one step at a time. And what I guess I'm trying to coach you on here is as it starts to look at each value of true or false, do I just automatically add a yes vote or do I need to do something else? I need to put an if statement in here. I don't know if you guys are figuring that out yet, right? So I have to ask
Mhm.
if should mascot singular vote if it equals or it really is equivalent to, okay, what's our first, if it's equivalent to true, then what happens? We're going to add 1 to the vote count, right? So we're going to say true is a yes. So we're going to say the yes count will plus equals 1. We're adding 1 to it. Then, oh, but we're going to have an else here, right? I could test again. I could just have a separate if statement or an else if that said, if it's false, add 1 to the other. But you know what's, it's either one or the other. So I really don't
Yeah.
test it. I can just say else. And then the code that follows that is just simply no count equals 1. And then it just keeps running through. Now notice in the sidebar, as I'm doing this, it's already tallied votes. So we have 125 yes votes and 75 no votes. It's already telling us, you know, and this is kind of nice. All right. It says, after the loop is finished, write an if statement that compares the two values and prints a different message based on whether the vote passed or failed. Okay, there I'm a little confused. I'm going to read this again just for my own sake. So like I'm kind of feeling your pain as students now. It's like, what do they mean by this? Right. And I'm trying not to look at the teacher answer key as I'm doing it. It says after the loop is finished, write an if statement that compares the two values and prints a different message based on whether the vote passed or failed. Okay. So what am I comparing? I think I got it. I'm comparing which one received the most votes. Okay, so here's the if statement. If yes count is greater than the no count. We're just gonna, we can just print, right? We can just say print. Now, do I need to run another test here? Do I need to? And the answer once again is no on this. This can go directly to an else. We don't have to check to see if the no vote. It's either the yes votes are greater or the other votes are greater. Is there actually a different scenario? Actually, there is a different scenario. The scenario would be if there's a tie. So actually we do need to test. How about that for a mind bender? So we're going to say else if no count is greater than yes count, like the reverse. And we're just going to copy this message. And see, I made the mistake of thinking about it. Chosen to not change our mascot, right? But there really is a third scenario.
Tie.
Yes. Let's paste that in too. And I'm going to say something a little more generic. The vote has resulted in a tie. So I'm just going to leave it at that. The votes resulted in a tie. I don't know what the result of that is. They just need to get one more person in there, perhaps. All right. Now, if you want to like keep ramping up this exercise, and I'm just kind of putting it out here for you guys, if you want to keep ramping this up, what they really want you to do next is to do the same code. And what I would do at this point, I would just copy all of this. And I'm just showing you this, right? And I know that you guys are trying to copy my stuff, and I'm going to repaste it down here. So basically we're going to reset the yes and the no, and then we're going to change these to match the next scenario, right? And the next scenario here would be should install coffee vending machines, boats. That's a mouthful. Holy cow, that's a mouthful. So I'm going to drop that in here, paste. And then I'm going to also paste it here and remove the S. And then since I did that, then I will copy this and drop it in here. And now we can count the votes again. Hopefully this works. I'm waiting for my playground here to catch up, and I think it's not liking it for some reason. All right. Why is it not liking it? Oh, I know why. Here, I've already, this is why I'm getting errors. I've already declared these as variables. And then I'm trying to do what? Redeclare them as variables, right? I don't need to do that. I just need to reset them to 0. Okay, there we go. So now we should get a count. There we go. Now this one is even. How do you like that? Right? Now, interestingly, because the if, I want you to think about this, because the if is written just to count yeses or nos, I can just repeat it, right? So I can just drop that in here. Ideally, I would actually make that a function, when I think about it, right? Because I'm repeating a whole block of code. This one did result in a tie, so I was smart to put in that third option. I didn't even realize that one of them was that. Now to repeat this process again, just creating a bunch of blank lines here, I would once again reset the yes and the no. I'm putting that here. And then I'm going to repeat the for loop, once again, changing the variable names. And I'm just going to come up here and I'm going to grab poll options. That's going to go here. Then I'm going to put it here and make it a singular. Take that singular and paste it here. And should get, okay, there's our vote results. And then once again, we can drop in that if statement afterwards to get the result. Yeah, and so here's the mistake that we are making. We're not changing our message. So the voters have chosen to install a coffee vending machine, right? Oops, all right, that's not what I meant to do. I did a control A on that very accidentally. And this one is chosen to increase our poll options. And this one is the converse, not to increase our poll options. All right. All right, and I know that I'm like bouncing around here and I apologize for that because it makes it hard for you guys to copy my code, right?
It's okay.
This is where you guys should start getting smart and doing like screen captures, right?
I did actually. right.
I'm I'm thinking here's how we're going to operate the rest of this, right? Because I know there's a bit of work left here, right? We
Mhm.
have a little bit of work left here on the page, and then we have a couple exercises that follow. So here's what I'm going to do. I'm going to actually stop the recording here, and rather than give you guys the answers, I'm going to task you for next week. So you can take the rest of the time that we would normally be in class to try to work through the rest of the exercises. And then when we come back next week, we'll take a look, see what's right and wrong, and fix the code, and then we'll move forward. 'Cause I think
Okay,
that'll be a good exercise for kind of ramping up your skills a little bit. It's nice to code with other people, but when it comes down to it and you're sitting on your own, I mean, that's often how programmers are working, trying to figure out problems. And I'm going to give you a couple of tips. If you're working on this and you get stuck, look at the examples, right? Try to figure it out. And if you can get it to work, fantastic. If you're really, really super stuck, you can go to the teacher version, right? And you can look at the solutions and then go, oh, that's what they meant, right? But they are pretty specific in what they're asking. And then when we get together next time, I'll show you how I would do it by manually coding through everything. And I think that's really helpful. And I think that'll help you guys a lot, because that way, at least you're doing a little bit of the struggle on your own part and trying to figure it out. And that's kind of the general goal of like teaching you guys how to do this stuff, is to be able to present you with challenging situations and you're seeing how to get there. Might not all resonate at once. It is a process, right? And just be patient with it. You can do it. It's just a matter of kind of sticking to the guidelines. All right, I'm going to stop the recording here, and then we'll pick up right here next time at the same spot, and we'll finish off the exercises.